Good evening, friends. We have one more problem on laminar flow in a circular pipe. So the statement of the problem is like this: a fluid of viscosity 0.7 Newton second per meter square and specific gravity 1.3 is flowing through a circular pipe of diameter 100 mm. The maximum shear stress at the pipe wall is also given. You are asked to find the pressure gradient, average velocity, and the Reynolds number. So here the solution will be going like this. So given that the viscosity is 0.7 Newton second per meter square, specific gravity is 1.3. In the sense, the given fluid is 1.3 times denser than the standard liquid, that is water, whose density is 1000. So it is 1.3 into 1000 becomes 1300 kg per meter cube. Diameter of the pipe is given as 100 millimeter converted into meter, so that is 0.1 meter. So here the shear stress what is given here is also written. Now the pressure gradient, so that is del P by del X. So the maximum shear stress equation is given as minus del P by del X into R by 2. So the shear stress is given, so that is 196.2 Newton per millimeter square, that is substituted here. So pressure gradient del P by del X to be found out. Radius is 0.05 meter divided by 2 here. So now pressure gradient is minus 7848 Newton per meter square per meter. So the pressure gradient is the ratio of difference in pressure to difference in length. So pressure is in Newton per meter square, length is in meter. So the overall unit for this pressure gradient is Newton per meter square per meter. Now the average velocity, it is proved that it is the maximum velocity divided by 2. So we are taking that equation, half of maximum velocity equation is this. Now del P by del X is calculated just now, substituting that del P by del X, and then we have 2 into 4 mu here, so that becomes 8 mu. So viscosity is also given, so that is substituted here. Radius is substituted here. So we are getting the average velocity as 3.5 meter per second. So this average velocity we are using in finding the Reynolds number also. So Reynolds number Re is given as rho into U bar into D divided by mu. So here your U bar is the average velocity just we obtained. So and density is also calculated as 1300 kg per meter cube. So that is substituted here into U bar. So that is 3.5 into diameter of the pipe. So that is 0.1 divided by mu. So that is viscosity. So that is also substituted here. So we are getting Reynolds number as 650. So if the Reynolds number is less than 2000, we conclude that the flow is viscous flow or the laminar flow. Since the Reynolds number obtained, that is 650, is less than 2000, so the given flow is laminar flow. So it is asked to find the three quantities here. So that is the pressure gradient, average velocity, and the Reynolds number. All the three were calculated here. Thank you.